Yo, back with another video. Okay, so in this video I'm going to tell you about that energy is not conserved, world is made of fields, not particles, and my speculations about theory of quantum gravity. So let's start. And the thing is, have you ever thought that energy is not conserved? In our schools, every day we are taught that energy is conserved, right? Always the two sides of equation are equal. But the thing is, that's not the entire truth. Energy is conserved, but not the way, like both sides of the equation are equal, not that way. Let me tell you how. So, have you ever heard the process of neutron decay? And in which a process, what happened that it is a neutron and it decays into proton, electron, and an anti-electron or anti-neutrino, whatever that is. So what had happened? So in the process, there is a particle found called W minus boson. And what happens at that W minus boson, the mass or energy of that particle is more than neutron, proton, electron, everything combined. Okay. So how it can happen? Just think of it. How it is possible so that we have a particle in a process which is greater than input and output, like like this is neutron, this is proton, electron, and neutron, and no proton, anti neutrino, and electron. Okay, charge conservation is there. I'm now asking, how is it possible? Here is here is 50 kilowatts or 50 GeVs. Here is 50 GeVs. In the process, how 80 GeVs is coming? It is not possible, right? But it is happening. So energy must not be conserved, like they used to say. But the thing is, that's not true. The explanation comes from quantum field theory, a theory which says world is made of fields and particles are excitations of that field, stable excitations. So what is happening? See, there is electron, right? And have you ever thought that two electrons repel each other? Electron repel each other. Why they repel each other? So you will say that, yeah, the some electric field is coming from here, some electric field is coming from here, they are like colliding. So where is that electric field? You don't know, right? So the thing is, this is not concrete theory, this is not concrete proof. The deeper question is why electrons repel. So you will say they both have negative charge. So what do you mean by negative charge? So quantum field theory says there are suppose so wait. Quantum field theory or in particle physics, there are some particles. That particles are excitation of fields, okay, and every field is coupled with other field. So every particle is coupled with another particle. Electron is coupled with proton, proton is coupled with electron, so electron is also coupled with photon. Fields overlap, or I say couple. So what happens? Electron is every time is coupled with proton field and photon field. Okay, so when electron is present in photon field, it has some coupling factor. It is 1 upon 137. I must think you have heard it in Veritasium, like 1 upon 137, whatever it is. This is also called fine structure constant. So the thing is, whenever two electrons come together, so electron is coupled with photon field, right? So what is happening now? Electron is electron is what happening is, like, electron is constantly producing waves, or I say photon waves. Wait, let me clear my explanation here. Electron is coupled with photon field, right? And that coupling causes emission of virtual photons in photon field. Now what do I mean by that? Emission of virtual photons in virtual field, no, photon field, sorry. So the thing is, this is electron and it is emitting photons. No, it is not emitting photons. It is coupled with photon field, and that coupling causes photon field to get disturbed and produce virtual particles. So every electron in classical sense producing every time virtual photons. So true electrons, when they come together, they are always producing virtual photons. So they come together. So the photon is like producing what virtual photons. And electrons is producing virtual photons. So they exchange momentum. So imagine throwing two balls at each other. If your friend and your friend throw balls at each other, just because of momentum transfer, you will repel. That's what happens. Photons are getting produced by electrons, virtual photons. They are not stable photons, they immediately get destroyed. Particles are stable excitations, virtual particles are not stable excitations. Right? So that's why what happens, two electrons repel. You can imagine two water pipes throwing water at each other and they are repelling. That's how electrons repel, and how like charges and how other charges attract positive negative. This is also a different theory. Now imagine two what say two water pipes throwing water away from each other in this direction. So momentum will this, and towards each other the momentum is this. So that's why how the what we say electric charges behave. So that confirmed first quantum field theory. And why quantum field theory became the greatest theory? Because it has accurate predictions than any other theory. It predicts accurately everything we experimented, more than any theory ever. So we have to accept it because numbers tell it. Okay, so where was I? So I was telling energy is not conserved. So what is happening in that neutron experiment? There is a neutron in neutron field. It wants to decay. So when it decays, that decay, when neutron tries to decay, it shakes a field. It shakes a membrane. You can it is neutron. It is coupled with W boson field. So when it tries to decay, it shakes the W boson field. So W boson field has got excitation. It's not stable one, but has excitation. So automatically from out of nowhere, W boson field has excitation. So your W boson, and then W boson decays into proton, electron, and that neutrino thing, whatever. So excitation, these stable excitations are giving us extra energy, but these excitations are destable. They don't follow uncertainty principle. They follow uncertainty principle. That's why, because we are creating energy out of nowhere, so we can't create energy. That energy, the thing is called stable energy and destable energy. Right? Stable energy and destable energy. Stable energy is us. We can live forever. But destable energy can live for a very, 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 very short amount of time. That's why it gets destroyed immediately. That's why W minus boson lives. We don't know how much time, but we know it lives. Experiments show that. Right? So energy conservation doesn't hold that there. But uncertainty principle holds, and that is main theory. Energy conservation is not a main theory. We can borrow, -1, -2, -3. So that time, energy of universe gets negative because we borrow it from the universe. Right. Now let's talk about. So the theory of everything. The last puzzle is gravity. We have explained weak force, W minus boson, strong force, gluons, and electrons, electromagnetic force, virtual photons. What about gravity as a force? Which field is responsible? Which particle is responsible? Graviton. Okay, so let me speculate about graviton. This is just a speculation. So Einstein said gravity is just bending of space and all that. Mass bends space, and that we call gravity. Einstein just said it. This. Okay. So when we came up with a quantum theory, when we come with a quantum theory of gravity, it should hold that theory, because that theory is God level theory, general theory of relativity. It is super duper accurate. If our quantum theory of gravity does not hold that, fake quantum theory of gravity, bullshit. So the thing is, now how do we create a theory of quantum gravity that holds that? So here is my speculation. See, imagine a field of gravitons. Okay. And now I will clear about nothing. What is nothing? Nothing. Nothing is nothing. Nothing is nothing. So, you say vacuum is nothing. Nothing is present in vacuum, right? But space is present in vacuum. You will also say that. So, graviton is present there? No. If graviton is present there, then there is space. So, when my whole argument is, if nothing is present, no space is there. In vacuum, always quantum fluctuations are there. I know this video will get to you only if you are a little bit good with theoretical physics. So in quantum, in vacuum there are always quantum fluctuations. Okay, so there are always virtual particles in vacuum, right? The thing is, particles create space. That is my theory. Particles create space. Mass creates space. Space is not a background. Mass creates space. How? The thing is, what creates mass? Higgs boson. Because Higgs boson is not there, every electron will be moving at the speed of light. It will not be a stable mass. Rest mass will be zero. So Higgs boson creates mass. I just want to say that. Okay. The thing is, Higgs boson creates mass. Higgs boson creates mass. So what? So I am saying then mass creates gravity. Mass creates space. So at this point, we need quantum theory of space, not gravity. So let's first come up with quantum theory of space. So what is I am saying quantum theory of space is, there is a field of gravity. Stick with me. There is a quantum theory of space in which, imagine, gravitons are present everywhere, but graviton field is present everywhere. Graviton field is present everywhere. Okay, graviton field is present everywhere, right? Thing is, if graviton field is present everywhere, but only excitation of that field will produce gravitons, and gravitons make space. If graviton field is not excited, nothing is there. You get my point? If graviton field is not excited, nothing is there. So what happens? Mass shakes the graviton field. Mass, presence of something shakes the graviton field, and that shaking causes stable excitations of graviton field. So graviton emerges, and that gravitons make up of space. And how it is consistent with quantum general relativity. So my point is, graviton mass produce stable excitations of field, graviton field. So what happens? The strength of excitation of graviton field depends on the mass, just as strength of electromagnetic force depends on charge. Just I'm just saying. So strength of decoupling factor here with mass and graviton field is what? Mass. how heavy the object is, how dense the object is, how much mass is present in it object. Okay, so that's what I'm saying. So what happens if excitation is more? If excitation is more, so what happens if excitation is more? So it bends the space more, and if bends the space more, then it is consistent with theory of relativity, general relativity. So my whole point is, if there is nothing in vacuum, not even quantum fluctuations, then vacuum doesn't exist. Always there is something in vacuum, virtual particles. That's why vacuum does exist. That's why graviton is present there stably, because always something is exciting graviton field, right? And presence of me is creating space around here. If I cease to exist, my every field disappears. Electron, proton, neutron, everything disappears. Space will cease to exist. Space can't survive without mass. It's not mass is being put into space. Space and mass exist because existence of other. You get my point? That's my theory is. There is nothing called a nothing. Nothing is, emptiness is not present in universe. Vacuum is also filled with particles and on the quantum scale. So I think now I will study quantum theory of gravity and try to understand if my speculations are correct, or these scientists are speculating these only, or they are speculating something else. Who knows? I know this video is a little bit dramatic and here, there, and mumbling, but yeah, take it. Bye bye.